Sorry guys, I gotta repeat what I just said. So this -1 right here just means we're putting the S on the bottom. It's saying 0.0815 per second. Okay, that is our growth constant. So we are growing in this problem. All right, we're talking about computer virus that's growing, blah, blah, blah. There's a bunch of stuff I don't need. I just need that guy. What was the doubling time of the virus? So how do we figure out when it doubles? Now, here, let's make, we're going to use an exponential function. So I'm going to say a of t equals a naught. So we have to have the starting value, e to the, and then we have the kt. Okay? So that's just a formula. That's nothing new for you guys. I'm using an a right now because we're talking about amounts. Because that's what it's talking about right here, like the amount of viruses. At what time does it double? Okay, so we have our beginning amount of viruses. What's the number that we want to double? Like, wrong question, sorry. So this is the beginning amount, and then do you guys remember what this was? The ending amount or the current amount, right? Okay, so it's that right there that we want to be the doubled number. Double of what? Double of the rate or double of the amount we started with? Amount we started with, right? So we're going to say this. We're going to say 2 a naught equals a naught e to the kt. So I want to find out when this amount doubles. And so I just wrote that in. And look how simple this becomes when it comes time to solve it. I want to find out, now I know what k is. K is given to us right there. I want to find out what's the doubling time. Like what t would double the amount? Like when would it actually double? So let's plug in k because we know it, and let's get rid of that a naught. Because if we divide both sides by a naught, the a naught's gone. Right? So we're just left with 2 equals, and we have e raised to the, and then we know k, it's 0.0815, and then we're multiplying that times t. Okay, does everybody see what just happened? Because it just got really simple all of a sudden. Do you know how to find out what t is? Logarithms. Natural log of both sides, so I take the natural log of that, I take the natural log of that, and I get the natural log of 2 equals 0.0815t. And then I would divide by 0.0815, and that would give me t. So this would be my doubling time. Now I did plug it. I plugged in a constant. Okay, if I didn't plug in a constant, what would be down here? Just a k, right? So that's actually a formula that the book says. Like, hey, if you want to find the doubling time, the the time at which it doubles, you just go natural log of 2 divided by k. And that works every time. It'll give you the doubling time. And so I could have just used this formula to begin with, but I like doing this more because it's more understanding in my opinion. All right, so can someone do that for me really fast? What is natural log of 2 divided by 0.0815? Oh, you guys already got it for me. You guys know me too well. So it's approximately equal to, say it again? 8.5. Cool. So this is our doubling time. The next question says, if the virus were to begin in 4 computers, how many hosts were infected after 2 minutes? So wait, that means this is minutes, right? We're in minutes right there? I think it says it. Oh, wait a second. We have a unit problem here. What is this supposed to be? Is this supposed to be seconds or is this supposed to be minutes? That's seconds. Right? That's what this S was right here. It's per second. Okay. So how are we going to figure out after 2 minutes? What are we going to plug into our function here? Here's our function. Our function is the amount of t, a of t equals the starting amount, which we know is 4 now, times e raised to the 0.0815. That's our, and then times t. So what would I plug into t so that I can find out how many hosts were infected after 2 minutes? What would I plug in t? Would I plug in 2? I'd plug in 120. Why? Because our rate, our constant, is in seconds. It's not in minutes. And so we would say a of 120. Now the rest of this is plug and chug. I mean, it's pretty much use your calculator. So I'm not going to finish this. but I'll tell you the answer. So you go 4 times e raised to this. And if you put it in your calculator, make sure you put parentheses around it. 4. So you get 70,700 computers or hosts. Okay, and then for 3 minutes, what would you plug in for 3 minutes? 180 seconds, right? You just multiply it by 60, and that problem is finished.